Hi there. My name's Ben Hale, and I'm the lead of the Java language for VMware across all cloud platforms. I'm also a founding member of the Cloud Native Buildpacks CNCF Sandbox project. Today, I'm here to talk to you a little bit about what Cloud Native Buildpacks are and how they work. So, the demo here today is going to show what it takes to actually use Cloud Native Buildpacks and to create a new Docker image that can be run on any platform such as Docker or Kubernetes or something like that. So the first thing we're going to be doing is using a product that comes out of the Cloud Native Buildpacks project called the Pac CLI. So the Pac CLI has a bunch of different commands in it, but the one that's interesting to us is this build command. And in the build command, we're going to go in here and say, I want to create an image based on this. We want to use as an input a particular jar file. And then there's just some other stuff that are going to make sure that in our Docker environment, things build well. Pack itself is simply one implementation of a platform that uses cloud native build packs. And there are many others. Heroku uses it, VMware uses it directly. We see things like GitLab using it, Google using it, bits of Microsoft are using it as well. It's a widespread standard that many people are using, and Pack CLI just happens to be one platform that happens to be useful at the CLI. So let's take a look back at exactly what happened here. So the very first thing we saw was a detecting phase. We see that in this particular instance, there are 16 possible build packs that might choose to participate when given our particular jar file. But each build pack has the opportunity to decide whether or not it wants to actually participate. And so we see that 5 of the build packs said that they would be candidates for using this for use with this particular jar file. So if we take a look, the very first one is this Paquetto Belsoft Liberica build pack. And what this does is it goes and drops a JRE into our image, adds some other stuff such as a memory calculator or an OpenSSL certificate loader that sort of does things to help a JVM run inside of a container in a better way. It turns out it's really, really difficult to do this. We want to make it as easy as possible for as many applications as possible. The next build pack that participates is the Paquetto executable jar build pack. And what this one says is, I recognize this is an executable jar file. I want to run this particular command. Java, setting its class path, allowing users to set some Java ops, and then finally executing a particular class inside of it. And then finally, we have a third kind of build pack, the Spring Boot build pack. And this says, hey, not only is this a Java application that needs a JVM, not only is this an executable jar file that needs to be run this way, I know some things about Spring Boot applications. I can take a look and see, hey, this is a reactive web application, and therefore it needs a certain number of threads dedicated to it. I know that you're using something like Spring Cloud and you want to do service binding, so we're going to contribute a jar file to that. We even slice up the application itself to help with caching and deduplication, and we set some image labels that go along with it. Finally, this particular image is exported out to a particular registry, this registry we see right here. If we take a look at that internally, what exactly do we see? We'll be using a utility here called dive, which is really, really useful. It basically allows you to take a look at the file system of an image and how it's pieced together. And so the first thing we see is the first couple of layers here are a bunch of different things that are effectively an Ubuntu Bionic operating system being set up with all of its certificates and things like that. And then eventually we get to where we start doing contributions from the build pack. We see that a layer has been created that has a class counter on it, maybe some security properties. Eventually we get to the point where we see a JRE has been contributed, this full standard JRE. We set some other environment variables, the certificate loader we mentioned earlier. We go and we take a look at the Spring Boot build pack. We see the Spring Cloud bindings, jar file is going to be there. And eventually we get to the actual application. This is a standard Spring Boot application with all of its dependencies on one layer, the loader application, jar launcher on another layer, the application itself just called demo application on yet a third layer. We split these up so that they have different life cycles. They change at different rates. Dependencies don't change nearly as much as applications do, which means that that 20 meg layer with all of your dependencies on it is likely already cached on your edge nodes or is deduplicated inside of a registry, saving you space, saving you transfer time. So we say we can build an image using these build packs, and that was pretty quick. If we take a look, we saw that it was about 17 seconds to do that particular build. But what happens if we do that build again? Oh, build. If we do that exact same build again, we actually can take advantage of a lot of the deduplication of layers that are already part of this image. We know that we were going to contribute Belsoft Liberica 11.0.8 previously, right? We did that. We can download a very small amount of metadata, say, am I going to contribute the same thing? If I'm going to contribute the same thing, don't transfer any data at all. Just use, here's a pointer to that layer. I want you to include that layer again when it comes time to build this thing. And this is sort of a trivial example where nothing has changed. And so all of the layers are rebuilt. We see that this time around it happened in something very small. My limit's at around 5 seconds, so something less than 5 seconds to actually rebuild this. But what you see is we see a lot of reuse. If one thing had changed, for example, if we had a different version of the JRE, that would have been the only layer that was recreated. If I change something about the web application type, that's the only layer that ends up getting recreated. So this is all sitting on a registry, and we say that what's created is a standard OCI or Docker image file. That means it can run on any platform, such as Kubernetes. It can run it. In this case, the platform that we want to run it on is actually my local Docker daemon. So we'll go ahead and do a Docker pull for this. Go ahead and grab that particular jar file. We already had it from Dive, and we'll go ahead and do a Docker run this time. And what we see is the application startup. We see some stuff such as how the Java memory configuration is calculated. We see it add a bunch of certificates to the JVM trust store. We do some stuff around Spring Cloud bindings. And eventually we have a started application here. And if you were to curl against this or something like that, you'd see exactly what you'd expect to see. Normal running application, and it would run exactly the same way on Kubernetes or Heroku or Cloud Foundry or any of these other platforms. So that's really, really interesting. But we can also go beyond that. Because of the way build packs create their images, they're not necessarily what you sort of think of in the old way of Docker images being created, where every single line in a Docker file is dependent on the execution of the line above it, which means that if you change any top level line, or if you change the from statement specifically, you have to rebuild absolutely everything underneath it. Build packs have this concept called rebasing. And rebasing basically says, if you have a stack or an operating system, right, we know what layers those are versus the layers that the build pack contributed and your application contributed. We can say, hey, what we want to do is actually take all of the upper layers, the stuff that's not the operating system, and pick them up and put them on top of a different operating system. And this is really commonly used to deal with security vulnerabilities. If there's, for example, another Heartbleed kind of thing coming up, OpenSSL has a vulnerability in it. What we want to be able to do is say, how do we get your applications to be safe as quickly as possible? And that's not to rebuild every single image. It's to take all the images you're currently using and put them on top of a new version of the operating system rather than rebuilding your Java application from scratch. So we have a command for that. That command's called pack rebase. I'm going to put time in front of it because it happens so quick. I want you to see exactly how quick it comes. And so in this case, we're going to say, hey, I want you to take that previously existing image and put it on top of a different run image. In this particular case, it's version 0061. So if we execute this, we see it happen. And according to this, it happened in 0.2 seconds, right? We effectively went to a registry, downloaded just the metadata about this image, none of the actual image data. We took a look at all of the layers that were referenced in it, removed the layers that were the old version of the operating system, added in a bunch of new layer pointers to the new layers in the operating system, and then push that metadata back up to the registry. So in the end, we probably transferred maybe 4 or 5 kilobytes of data rather than the 100 megs of data that this image actually is. We should be able to Docker pull this again. We go and we download just the new layers for the operating system. The stuff that came out of our particular application already exists locally. We don't get any new data for this. And then finally, We can do a Docker run. And now we're starting that exact same application without changing the JRE that was on it, without recompiling the Java or changing any of the configuration parameters or even rebuilding the image, really. We can restart that with a new, safer version of the operating system. So thank you for your time. If you have more questions about the Cloud Native Buildpacks project generally, again, as I said, it's in the CNCF sandbox at the moment, we'd be happy to talk to you about it. Thank you very much.